Good afternoon, good morning to those dialing in from the U.S., good evening to the Middle East and Asia and Europe. Good afternoon. Thank you for dialing in. Really excited to be here on another very interesting, insightful, and educational session on distributed denial of service attacks. And I have a very special guest who is going to share with you, pretty much as it says on the tin, architecting a sophisticated DDoS attack. A couple of hygiene issues, obviously, before we begin. The presenters are myself, the one on the right with the blue turban, Karsten. He is the main specialist here. He's going to talk detail about this. Your opportunity to put questions to him. Obviously, we're also going to show you how to protect from a DDoS that can completely disable your business. And Atish, and that's his BBC photo, he very happily provides every time we ask him. And a couple of hygiene issues, yes. So save yourself. You can always come back and record. This session is recorded. I'm going to give Atish a little bit of seconds to describe Link 11, where Atish and Karsten are from, has just produced a report on DDoS. And after this webinar, not now, after this webinar, we are going to have the report available for download. So please do keep that in mind. You can come in and download that report after this webinar. Atish, over to you, sir. Introduce yourself a little bit, and what is this report about?
Thank you. Yeah, Amar. So Atish Patney, I'm the Regional Director for UK and Ireland for Link 11. It's a pleasure to be here today. So as well as protecting our clients from DDoS attacks, every quarter, Link 11 produces an analysis of all of the attacks that we mitigate, and we produce a quarterly report that really shows the state of DDoS, particularly across Europe. So in that report, and it's available freely, that report will contain analysis on the top countries that are attacking organizations. It gives you some statistics on the number of attacks per day, the average number of attacks. For example, in one day alone in August, we saw 885 attacks to multiple clients in just a single day.
Sorry, come again, Atish. I'm going to stop you. 885 different DDoS attacks.
That is correct, yes. 885 attacks against individual customers in just one day. I think it was the 21st of August was the busiest day of the quarter. Wow. Overall, we actually saw a 71% increase across the whole quarter in terms of attacks compared to Q2. So you get to see things like that. You get to see, I won't steal too much of Karsten's thunder, but you'll get to see some numbers on kind of the size of attacks and how we're seeing an increase in that, how we're seeing the trends that we're seeing in terms of multi-vector attacks, and how today 58% of the attacks that we see are actually smaller but multi-vector, which are causing far more headache, and again, Karsten will talk about that later. You get to see information in that report on kind of the average time an attack lasts, where attacks originate, not just in terms of countries, but in terms of systems. I think, there's some myths out there about botnets and IoT devices being the only source of attacks. So again, there's a lot of information in that report. It's something that we do produce as a quarterly report. So for those who are interested in it, I would also suggest signing up to the Link 11 newsletter on our website so they can get the future reports as well. Excellent.
So just a reminder, folks, come back in about after you finish looking at this. We're going to be uploading that report. There's exciting information. One of the takeaways is 885 individual DDoS attacks. That is in one day in August, which is supposed to be a holiday season in a lot of Europe.
Excellent. Yeah, so, and I think that's the point. Holiday for us is not holiday for the attackers.
Not for the attackers. Although attackers do take holidays, but different times.
They take it when there's absolutely nothing to gain.
Nothing to gain, yes. So, Karsten, I'm going to come to you in a second, and Actually, you know what? Let me do this. So, Karsten, introduce yourself. Talk a little bit about obviously your technical expertise. But one of the questions we get asked a lot, I'm sure you also get asked a lot, is what exactly is a DDoS attack?
Sure. Hello, I'm Karsten. I'm the co-founder and Chief Technology Officer for Link 11. And as Tish already mentioned, we provide anti-DDoS service to our clients. And the technology behind the service that we offer is something that was primarily developed by myself and my team. And that is something that we offer to the worldwide internet as a service right now. And
Excellent. So what, Karsten?
Yes.
Going back to this focus of, a DDoS attack is normally associated with very, very large numbers. I think, Atish, we were discussing what terabytes, they've gone into terabytes now. But Karsten, what is a DDoS attack? What is the definition in your opinion? You do this on a daily basis, in and out.
Yep.
What is a DDoS attack?
Yeah, and you're absolutely right. One of the key factors of one type of DDoS attacks is the terabit or gigabit value associated with it. That means simply having enough traffic go towards your victim or that going towards the victim so that all his internet uplinks, maybe even the internet uplinks of his ISP himself, are completely overloaded and simply can't handle the traffic. So it's an infrastructure attack against the victim. The other type of DDoS attack, which we're getting into more detail later, is actually the more interesting one. And these are attacks that really don't take or don't need as much bandwidth. They are not trying to overload the infrastructure, the network infrastructure. They are trying to attack applications. They are trying to exploit vulnerabilities in the protocols. They are trying to simply gain resource usage, an increase in resource usage on a server or on a load balancer, on a firewall, and with that they are trying to overload individual services. And those are the two types of DDoS attacks. There are various subtypes, but we can go into more detail about that later.
No, excellent, and that's what I think we are leading to. But there are a couple of questions coming in, so let me just get to the questions. The other one is, what is the difference between a simple attack and a sophisticated attack?
Yeah.
Is there an easy definition of that?
I'm not sure if there's an easy definition, but we can say a brute force attack is, while not the most easy to start or to architect, it is not one that takes a lot of ingenuity or a lot of intelligence. It's simply getting more bandwidth than the victim has available. So that would be one of the less sophisticated attacks. And then there are these attacks that exploit specific services, specific protocols, and those you need to have insight into what you are attacking or what the attacker is trying to achieve. And that could be something, let's take an example, a web shop that has a search feature where you can search for products. And searches generally are not as cacheable as other objects in the website. So an attacker might say, okay, I'm not going to attack the website directly because that is already cached, maybe in a CDN or in a very fast load balancer, but he might attack the search site, which requires a lot less hits, a lot less requests than another attack would have. So in that, he's exploiting the architecture of the website, where a search engine or a search requires a connection to the database server, which generates load, which then is much easier to overload. So I would say a sophisticated attack is really something that's tailor-made for a specific application or a specific service. And that then requires a lot fewer resources on part of the attacker.
Interesting. And I think if I may, the media, and I'm not blaming the media, but Cyber Management Alliance also has a like 40 or 50,000 subscriber base, so we are almost like a media organization also. But a lot of the media often portrays a DDoS attack as a purely terabyte, gigabyte only attack, right?
Yeah. Yeah, absolutely, and that makes a lot of sense.
To take the headline. But are we saying it's much more than that, correct?
Yes, absolutely. While I completely understand why these huge numbers that have never been seen before are grabbing headlines, they are really not the interesting part of our job. Because, well, to mitigate them, you simply need to have more bandwidth available than the attack size. So that's just a problem of, to put it bluntly, throwing money at the problem. You just need to add additional uplinks, additional ISPs, and then the problem basically fixes itself. Where it becomes interesting and where our technology really shines is with these attacks that don't require a lot of bandwidth, but are especially tailor-made against our victims or our customers, which become victims, and that is where the intelligence and I would also say the fun part actually starts.
Interesting. So just to rephrase, if I may, and this is quite important to understand, I guess, for everyone listening in, it's not, the complexity does not mean volume. Yeah, complexity could be a web application attack, which will still cause a denial of service. So we need to also think of DDoS as a distributed attack on a web application, but not only as a terabyte, gigabyte, petabyte, packet attack.
Absolutely.
Excellent. So, Karsten, you're the hero of the show, as I said earlier, and as you can see on the image, the attack. So I'm going to move the slides, or you can move them along. Before we get to the detail, there is this one slide we prepared. If you can talk a little bit about it, and then start describing how you would create, in the first instance, a sophisticated attack, not a volumetric attack, but a sophisticated attack.
Sure. Yes, I mean, in this slide, and we've all seen articles like that or similar articles in multiple news media, DDoS is a problem, and I think the worldwide audience has realized that DDoS is a problem, and especially what happens after the DDoS attack has been successful or even unsuccessful, in that there's a lot of collateral damage that happens when DDoS attacks actually strike. And so that's why it's grabbing headlines. That's why we see outages even with websites or countries where entire countries are getting hurt by DDoS attacks that we would not expect otherwise. And on a similar note, collateral damage, often DDoS attacks are not the only attacks running concurrently. Oftentimes DDoS attacks are used as a diversion to occupy management resources or network operation resources, while a data exfiltration attack happens simultaneously. So that the attacker simply hopes that the admins are too busy handling the DDoS attack, while, yes, he can do his dirty business elsewhere, undetected or later detected. Yes, I would say we can go to the next slide, unless you have something to add.
No, sorry, I was just waiting for you. Thank you for that. Yes. So
yes,
now we're going to talk about the attack. So this is now, just for the audience, this will get a bit technical. If you have any questions, this is your time. It's not easy to get hold of Karsten, so we have to nail him down. He is tied to a chair. I'm just kidding. And Karsten, is over to you, sir.
Sure. So yes, we have 5 steps that are necessary to launch a, not necessarily multi-vector DDoS attack, but to launch any kind of successful DDoS attack. And next slide, please. Yes, the first step, identifying the victim. I guess I don't have to say much more about that. You have to know as an attacker who you want to attack. And this could be as general as, okay, I want to attack the BBC. as an attacker, want to attack the BBC. I don't know. Maybe they've written an article that I don't like, or I just gain fame within my peer group. I'm the one who's disabled the BBC website, and infamy. So that's step one. Step two.
Sorry, just on that note, and I strongly recommend everybody listening, don't try this, but from experience, if you do write an article, a blog about two countries, one of them Tibet and the other one Taiwan, and if you say anything very positive about them and negative about the other country, as you know which one I'm talking about, there is a very high likelihood, this is from experience, of a volumetric disabling DDoS attack on your website. So don't try it unless you have Link 11 or somebody else protecting you. But if you want to see the power of a nation, try to write a blog negative about the major nation and positive about Tibet or Taiwan. It is actually very interesting. Yes, over to you, sir.
Yeah, that's something that we see as well, and that some of our customers get hit a lot, and news magazines, and we can sometimes predict when an attack is going to happen simply by looking at the headlines. That's absolutely excellent. So next slide, please. Yes, step two, gathering intel about the victim. That means, at the very least, since a DDoS attack is targeted against network infrastructure or services, you have to find out about, okay, what do I want to attack on an internet level? And that would, for example, be the website of the BBC or the email server of the BBC. So you have to, and I'm going to get into more detail after describing the steps necessary in a bit. But it's about enumerating the available services. And then in the next slide, it is about, okay, now I've gathered all the intel, I'm analyzing it. Now it's about finding weak spots, because oftentimes that is something that we see, is that websites are actually well protected. Maybe you are, or the victim, the potential victim is in a cloud. So the DDoS attack is not hitting his own infrastructure or its own infrastructure, or he already is protected either by a CDN like one of our competitors, or there are different ways, but then the rest of the infrastructure, for example, the mail server, the name server, or even the campus infrastructure, they are not protected at all. And so it is about finding out if you can find this campus infrastructure. And yes, when you then have identified these weak spots that are not protected, for example, the mail server, then you select an attack vector or multiple attack vectors that target this service especially. For example, sending a lot of junk email would be also, or that could be considered a DDoS attack. And yes, then in the next slide, please, it's about starting the attack, which can either, depending on your own resources as an attacker, can be your own botnet, your own network of hacked computers or IoT devices like IP cameras or DVRs. Or you can also hire a DDoS service that unfortunately exists quite a lot in the internet, where you can simply put in the destination, select from a drop-down menu which type of attack you want to run, click on start, and then the attack starts. So you don't even have to do a lot of the attack orchestration yourself as an attacker. And then a very important step is on the next slide. It is about monitoring and adjusting the attack. That means oftentimes, let's say you want to attack the website, the main website of your victim. The attack either is not successful or was successful for a bit, and then the admins on the other side try to prevent the attack, try to mitigate it, and then it's no longer successful simply because they have blocked it. And since you want them to suffer, you want them to be down, you have to adjust your attack. You have to find a different target. So as in the intel gathering phase before, it's not only about selecting the best or the most vulnerable weak spot. It's having a list of weak spots so that if one weak spot no longer is a weak spot, that you as an attacker are not wasting your resources on this weak spot, but can simply just move on to the next one, and then the next one, and then the next one, thereby, of course, increasing the pain of the attack felt by the victim. So back to the intel gathering phase. Fortunately or unfortunately, depending on which side of the fence you're on, there's a lot of open source intel available where you can simply download information about which kind of, let's say, web servers are running on which IP address, which kind of other services are running. These are searchable databases available and on a lot of different websites where you don't have to pay, there's just information there. So first step would be to find out, okay, what kind of service do I want to attack? Let's in this case choose the website. Then you can look for TLS certificates that show a certain web service, or you can just look which websites are running. You can do a Google search, for example, and then next slide, please. Yes, and this would be, and I've chosen my example as the BBC. And these are options just by looking up DNS information about the BBC website or about the BBC domain name that you can find out. And what we see by that, in the first line, we are asking the name server about, please tell me the IP addresses associated with bbc.co.uk. And it's returning 4 IP addresses. And yes, those would be, for example, IP addresses that an attacker might want to attack. So then we query the same web server and ask, okay, please give me www.bbc.co.uk. And well, what we see here is that this website, or the www website, is behind the it's behind the Amazon cloud service. So, well, these are IP addresses that are already hosted with Amazon. Amazon, of course, being a huge network provider or a huge cloud service. So what we can gather from that is that an attack with a lot of bandwidth is most likely not going to succeed, simply because Amazon has a lot of bandwidth. And yes, in the next part, we are asking BBC, well, which name server is your domain hosted on? And it's replying with these 4 name servers. Then we are asking about what is the IP address behind those name servers. And again, we find IP addresses from the same range as the BBC website in the very beginning. So we have really not found anything interesting there and additional. But then the next one is actually the important one, in that we ask the name server to please tell us the authority, your state of authority. And that means please give us a little bit of information about the domain name that you're hosting. And what we see there, the 4th part, is that the name server that is primarily responsible for bbc.co.uk is ns, or yes, it's ns.bbc.co.uk, which was not returned when we were asking about the name servers about bbc.co.uk before. So that is something that the BBC wants to keep hidden from the worldwide internet. And by the way, they are not doing a very good job of hiding their primary name server. And so the next step, yes, we are asking for the IP address behind that, and we are getting a IP from an IP range that we haven't seen before. So one might conclude that this is an IP address that is exposed, or at least that is in a different infrastructure where maybe the BBC has not paid as much attention to when it comes to protecting this IP range. Next slide, please.
Sorry, Karsten, if you don't mind, can you just expand on that topic a little bit? So we are looking at the command of host -t, correct?
Yes, yeah, exactly. Host -t, and then the parameter behind that tells us the type of DNS response that we want to get.
Mm-hmm. The A record.
Yes, exactly. In this case, it is the A record, which maps a name to an IP address.
Yeah.
And yes.
But just to go back a little bit, sorry, there's a question there that I'm asking. So earlier we were saying that BBC has hidden the IP address, but now we're saying no. So there's a bit of confusion.
Yeah, exactly. But it's not really confusion in that I would assume, and I haven't checked it, I didn't try to attack the BBC, just spoiler alert, this is all theoretical. They were trying to hide this primary name server, and the technical term for the setup that they are running is actually called, it's a hidden primary setup, where the real primary name server is not known to the wider internet community. So in this case, yes, they tried to do that, but they didn't really do a good job. And that ties into I don't know, it's not the main point of this talk, but this ties into what I'm saying every day from morning to evening. Security is hard, and you can't really afford to make mistakes. And this might just be one little oversight where they didn't think about, okay, so if we convert our old name server setup to a setup where we want to hide the primary name server, we also have to change this little value in one of our configuration files. And it might be that they've simply forgotten to do that. Or another explanation might be that this network, this additional network that you see below, also is DDoS protected. That might also be the case, but generally what we see is that a lot of providers, a lot of our customers make small little mistakes that expose sensitive data.
Interesting. Very, very insightful. So moving on to the next slide.
Yes.
There is a question on tools, but let's address that later on. Okay?
Okay.
Yeah.
Okay. Yeah. This is just an additional DNS request where we queried the name server about the SPF record, which is the sender policy framework, as it's called. And this is basically a record that tells the internet community which networks are allowed to send emails from a bbc.co.uk domain name. So it basically lists all the IP ranges that the BBC has. And that is something you do for spam protection, so that other ISPs, for example, Google, can say, oops, I'm getting an email that claims to be from BBC, but is not sent from a valid IP range from BBC, so I'm going to drop it, or I'm going to mark it as spam. So there's a reason to have that, but again, it exposes a lot of potentially sensitive information and publishes it for everyone to see in the internet. Now again, this does not mean that these networks are exposed and shouldn't be exposed, but it simply means security is hard and you really have to make sure that data you publish is sanitized, that someone who knows what he's doing has looked at it and has decided, okay, this we want to do, this we can do, and this we shouldn't do. And in this case, in my experience, listing that many IP addresses in a SPF record might not be the smartest idea.
Very, very good point. Folks, just to clarify, SPF stands for Sender Policy Framework. And regardless, I agree with what you're saying, Karsten, sorry, but if you don't have SPF, you should look at it, because if enabling SPF and the other DMARC and DKIM properly will stop people pretending to be your domain name. But yes, Karsten, you make a very interesting point. As part of reconnaissance, the amount of information that we are seeing over here is pretty excessive, and if you're going to publish that information, I guess what we are saying is you want to make sure that you're protecting and have all the necessary controls on those servers, correct?
Yes, absolutely. Like I said, it doesn't mean that this is a bad idea to publish all of that information. It's something that stands out as someone, for someone who's looking at it from which types of services I want to attack perspective. And in my experience, usually the main directive under you want to see your entire security is do or publish or expose as little as possible. A principle of doing the smallest amount of public information, which some might call security by obscurity, which is like a frowned upon thing to do, but it works. Reducing attack surface, not exposing services to the internet that are not necessarily exposed to the internet, definitely makes sense, because if there's no service running towards the internet, then it's unable, or you can't attack it as an attacker. And in this case, I would say the BBC maybe is exposing too much information to the internet.
Yes, so just to reiterate, very important point, folks. Be aware of what you are exposing. We are not saying don't do SPF, to be very clear. We are saying you must do SPF. What we are saying is be and check what details you are exposing. I want to add a little bit here, Karsten.
Sure.
Some of the most sophisticated attacks require reconnaissance. And that's why, Karsten, I think you're going also is the more recon information available to a criminal, to an attacker, the more successful he or she is going to be. So this is very important to understand. So yes, obscurity, very important. So you need to figure out what is available. And this is kind of what Karsten is getting to, that the amount of planning required, if you give everything up, then the attacker is going to be very successful.
Yes, exactly. The more information the attacker has available, the more weak spots he can identify. And yes, in this case, I'm not saying don't do SPF. I'm saying do SPF, but be very clear, or think twice or thrice, or as many times as possible about what kind of information you want to publish in your SPF record as in every other record. And that simply is, yes, let's do that. I think the next slide is showing a trace route towards the name server that we've identified before, simply to check if or how the network path towards that destination looks. And that was a picture taken from my desktop, so that's the path it takes from my desktop PC. And what we see by that is not that much, but one thing that we do see is in the line numbered 6, for example, that this most likely is a Juniper-based router that might be in a data center that's called Telehouse, and that is then connected to one additional device, maybe a load balancer, maybe a firewall, maybe an internal router, that then routes to something that is named Gate A. And Gate A usually is something that might be a gateway, that might be a firewall, again, but most likely it is not a very high-powered device. So from this we can see that, for example, a DDoS attack with a large bandwidth might be successful, because the device at the very end might not have the capacity available to handle our attack. There's not much more to see in this trace route, but you can do a lot more. You can look at the network architecture. You can try to guess from the names that people put in the reverse DNS, like in this case in line 6, the AE0, what most likely the network setup is. And in this case, AE0 means it's an aggregated Ethernet device. So there's multiple Ethernet ports aggregated, and generally you aggregate either 1 gigabit interfaces, 10 gigabit interfaces, maybe 100 gigabit interfaces. So we can guess that this most likely has, I'm saying like 20, 40, maybe 100 gigabits of capacity at the most, but most likely much less, because these AE interfaces, in this case AE0, are numbered from 0 to whatever. So since this device, as the main entry point for the network, is named AE0, we can guess that it's not a device that has a lot of different aggregated Ethernet ports. So again, this is all guesswork, but that is part of the It's trying to get as much information as possible. And this might be a weak spot. It might not be a weak spot, but yes, it can go on the, let's say, on the maybe pile for possible attack destinations.
Okay, so a couple of questions. So now one of the things that comes up, and someone has asked this question, this is all good information, but I mean, in terms of link 11, how does this work? I mean, what are you doing to detect the launch? So the reconnaissance is good.
Yes.
Now what happens next? What is the attack vector here? And you know, we're not, just for the record, we're not saying attack anyone. This is an educational webinar, as much as there is education available elsewhere. So how does link 11 fit in? As in, what are you doing now that the attacker has done the reconnaissance and
yes.
he or she is going to launch an attack? What technology, what algorithms, what is the thought process behind link 11 coming and, you know, kind of defending and detecting this?
Yeah, exactly. But our work actually starts one step before that, in that we actually help our customers with exactly the intel gathering steps that we did before, and that we tell them, okay, maybe this is a problem, we've analyzed your network, we've tried to get a little bit of information, and maybe this is a problem, and maybe look at that again. So we start with consulting and trying to harden your network against any types of attack. That's step one. And then step two is, okay, now an attack has actually happened. What do we do? And Link 11, as a DDoS mitigation company, simply works for the customer as if we were just an additional ISP or even the only ISP. So that means that all the attack traffic that comes through to the customer transitions through or transits through our network. And within our network that is globally distributed, and we have multiple scrubbing centers, for example, one in London, one in Frankfurt, one in Amsterdam, one in New York, Los Angeles, Singapore, so worldwide scrubbing center distribution. And we analyze what kind of traffic comes into the network of the customer. And with that, we can detect attacks, we can detect anomalies, and we can, yes, then start to filter out traffic. And in the case for the BBC, for example, while the BBC is an international website, I would say, or I would guess without knowing and without having looked at the numbers, that most of BBC's traffic might actually come from within the UK. And so if, for example, we were as an ISP for the BBC, and we suddenly see an increase in traffic from Miami in the United States, then that would be something that our algorithms would detect as an anomaly. This does not mean that this anomaly is necessarily bad, because it might just be that, I don't know, maybe there was a nightclub shooting in Miami, and so a lot of people are trying to get news, and maybe the BBC was first with publishing this news. So anomaly does not automatically mean attack, but anomaly means anomaly. That is something that our architecture, our algorithms keep an eye on. And if multiple anomalies come together, and in addition, the website maybe starts to slow down or is no longer available, then our mitigation algorithms kick in and start to reduce the anomalous traffic back down to levels that the backend can handle. And this is pretty much the, I would say, bird's eye view onto how we work. It's an anomaly detection engine that, in case of an attack, tries to reduce the anomalous traffic.
So I have a question here, and this is very important because we offer obviously training in incident response and whatnot. And one of the things I talk, and I'm very passionate about, is time to respond. Yeah. How does this work? What are you doing to be able to respond quickly? Am I making sense in my question?
Yes, absolutely. That is actually one of the key factors that we focused on while developing our DDoS solution. Because let's take a step back and look at how DDoS protection was done, I would say, in the past, or is done by some of our competitors, in that you buy a temporary setup, a standby setup. So in the normal case, the traffic comes through the normal ISPs, the normal links you already have as an ISP or as an internet customer in some kind. And when the DDoS attack hits, the DDoS attack hits your network and is saturating your links, because you usually don't have this kind of multiple 100 gigabits or terabits capacity available. So the first thing you notice when there's a DDoS attack is my service is down. And then you phone or you call your DDoS mitigation company and say, oh, guys, I'm getting attacked. Can we please start our emergency process? And this might then trigger a BGP rerouting or a DNS failover. But that is all something that takes time. In the best case, it's, I would say, 10 minutes, 15 minutes in the lower end. But in the higher end, it's getting up to an hour or two, depending on, I don't know, we've had situations with customers that had experiences like that in the past before they came to us, where the person that had to sign off on triggering the BGP rerouting was currently on an airplane and couldn't sign off. So they had to activate their CEO to override this, or to basically give his authorization. And that took hours. So while during all that, of course, the website, your service is down. So what we do differently than that is that while we also offer the standby services, because some customers simply are not ready for permanent protection, but we try to offer a permanent protection so that we are an additional ISP, and all the traffic simply comes through to our links, or comes through our lines, comes through our mitigation technology. And so there is no triggering a rerouting. There is no manual process in that. It's all automated. And that leads to response time in, I think we are guaranteeing an SLA that's sub 10 seconds. So the impact of an attack is guaranteed to be less than 10 seconds. And it's good that it is less than 10 seconds, because longer impacts usually lead to collateral damage. And that means, for example, if your website, if your service or your network gets an attack and is even down for a minute, that usually triggers timeouts and other kinds of services. For example, you have IPsec connections, VPN tunnels to either road warriors or to other data centers. These would usually time out, and some of these then don't start automatically again. So even after the DDoS attack has stopped or the mitigation has kicked in after a minute, some of your services are still down. So it's absolutely essential that a DDoS mitigation starts not after a minute, not after 10 minutes, and not after hours, but within a few seconds. And that is something that we offer, and that was one of the key design decisions that we took from the very start, that we said, okay, this has to be quick. The mitigations have to start immediately.
Which means you are able to obviously detect quickly, because you have to then respond, yeah?
Yeah, absolutely. The detection is running all the time. Since we see the traffic all the time, we are always on, we are always looking at anomalies, seeing traffic levels increase, seeing traffic that we didn't see before. Yes, this of course allows us to react automatically very, very, very quickly. Simply
so here's a question from the audience. Sorry to interrupt you. And it's a
Sure.
good question. Based on what you're seeing so much traffic, you obviously are living and breathing the product, designing it, etc. What in 2019 is around the corner? We are towards the end of 2018. What in terms of denial of service, DDoS, what should they prepare for? What should people listening in, what kind of threat, other than volumetric, but what kind of threat, any specific, if you can share, that would be very insightful and useful.
Yeah, of course, and that is actually what we do every day, because yes, like the question mentions, and as I've said before, volumetric is just a war of money. You can throw more money at the problem and then it's fixed. But what we see increasingly is botnets getting larger and getting more intelligent. That means, let's say, the Mirai botnet that went through the news 2 years ago had, I think it was like 10 or 15 different types of attack. Some of them were just generating random packets, which are easily detected and easily dropped. Some were a little better. For example, the DNS water torture attack that took down half of the United States DNS service because they were attacking the DNS provider, Dune.com, for Twitter, for, I think, Facebook, for Amazon. .de, I believe it was. .com was protected, but .de was down. And yes, so what we will see increasingly in the future, and this has already started, is that attackers and attacks get smarter. They are no longer just looking to spew packets at the destination, trying to overload routing tables, forwarding tables, routers, and links, but they are actually trying to attack protocols at a very understanding level. That means they try to design their attacks, for example, like I said before, the website, the online shop with its search page, they might try to attack the search page and not just hammering the same website, the index website that is cached and is not having that big of an impact. So where it goes into the future, or when looking at the future, I'm pretty sure that attacks will get smarter and will understand more and more protocols. For example, or another example, 5 years ago, we did not see a single SSL-based attack, simply because botnets were not smart enough yet to target SSL or TLS encrypted traffic. Nowadays they are, and nowadays they do. So back then it was pretty easy. When you had a protected website, a TLS protected website, you could just disable port 80 and forward everything to port 443 to HTTPS, and your website was pretty much safe from, well, still not from the attack bandwidth, but you were safe from attacks exploiting, for example, the search page. So nowadays that no longer works, and that is a situation that we see with different protocols more and more, where attackers actually take their time, analyze protocols, and try to work in specific attacks, to target protocols, and try to exploit weaknesses there.
Okay, now this is very interesting. Sorry.
Amar,
yes, Atish. Yes.
Just to add to that, one of the other big predictions that we're seeing for next year is a fundamental change in the underlying motivation of DDoS attacks. So we talked earlier about DDoS being about disrupting a website, maybe to take something down for political reasons. But what we are seeing is that next year is very much going to be the year of DDoS being the new flavor of ransomware. So extortionware is a wider concept, is something we're seeing a lot more. And it's basically ransomware in terms of encryption software for endpoints is getting more and more expensive to launch as a sophisticated attack as we've started protecting the endpoint. DDoS as a ransomware is actually getting cheaper for the attackers to run because of some of the services that Karsten mentioned earlier. So actually, if I'm an attacker, it's cheaper to try and take down your infrastructure or your website for ransom than it is to try and get code onto your endpoint.
So thank you for that. Very insightful. So I guess what I'm going to suggest, and please correct me if I'm wrong, is you really need to, one of the kind of mandatory things that we recommend, even we still recommend our customers, our clients, is to focus on ensuring that a regular volumetric attack doesn't affect you, right? And that means engaging someone like Link 11 who, remember, the problem is volumetric attacks are relatively straightforward. They're not complex, and they're not sophisticated. So if I may, even babies can launch a rough volumetric kind of attack.
$10 an hour, you can just buy it as a service.
That's it. And what we are saying is, make sure you protect against those baby, non-sophisticated attacks, so you can then focus on those that are targeting SSL, those that are targeting specific web application apps, protocols, and that's coming to that. And final, I know we could talk about this for a long time. One question on this is, so coming back to the sophisticated attack, are you also, as in Link 11, are you monitoring the protocols to baseline them? Am I making sense?
Yes.
How are you detecting that?
Mm-hmm. Yeah, exactly. That is the very core of our technology, in that the anomaly detection works on two levels. One being the network. Do we see a lot of, for example, ICMP traffic coming in that we didn't see before? So yes, we detect anomalies on that level, but we are also looking at the actual protocols. And for example, in this case, our website, the website, we might analyze a protocol. We might analyze a web visitor of a website. Let's take our online shop again. The client visits the online shop, maybe clicks on the offer of the day, maybe he searches for 2 or 3 products, then he puts them in his basket, checks out, pays for it, and usually does not return within a few hours. So this might be our average user profile. So when someone visits the website, a new client visits the website, we would expect him to behave similarly. If he doesn't, again, this is not a problem. We would detect that as an anomaly, but as long as the backend server is still replying within a certain amount of time, so he's not overloaded and the website basically is working fine, then we would still let this customer or this client through. But in case where the web server is starting to slow down or there are service outages, then we would simply look at which types of clients that are currently visiting the website are most likely or are closest to our average user that we've learned before from the baselining. And then we would just sort the list and throw out everything above a certain threshold. And so that would mean that the client's website, the victim's website, is still available to the vast majority of his visitors. And yes, that might mean that someone, for example, who is on vacation somewhere where he's not usually from, then he would also be detected as an anomaly. But in this case, this one false positive or the low number of false positives are not a problem, because the alternative would be if there were no false positives, then the website would be down, simply because there would be too much traffic being forwarded towards the backend server. So the system basically has a choice as to either it's down for everyone or it's working for almost everybody and not for the exceptions. And this is a pretty easy choice when it comes to DDoS.
Very good point. Very good point. So we're coming towards the end of the presentation. If there are many more questions, I mean, we've answered as many as there were. If you do want to ask any more, now is the time. Just to reiterate, we are going to upload a report in about half an hour. So do come back, or in maximum 1 hour, do come back and download that report. Is a kind of hot off the press report that Link 11 is produced around some of the state of the DDoS threat vector. And just to remember this, folks, when people say DDoS, it's not just a volumetric attack. They are not necessarily sophisticated, many of them. So what we've learned here, I mean, we could spend another hour, I know, but we will definitely come back by next year with more details on what you can do. But for now, I think one final question has come in on SPF. What do you recommend, very quickly if you can, Karsten, without taking too much time? How does someone stop? Let me go back to that slide. So this was the slide, I think, on SPF. How does someone stop or hide all this data but still implement SPF?
Yeah, For example, usually the clients don't, or the clients on the customer side, the Windows machines, which are running Outlook or some other mail program, they are not directly sending email to Google, but they are using a mail server that's hosted within the company's network. So what you do with SPF usually would be to just whitelist this one IP address of your mail server, or maybe 2 or 3 if you have them running redundantly, but definitely not all of your client IPs. So this eliminates this problem basically, so that you only expose 3 IP addresses instead of thousands.
I understand. Yeah, I mean, SPF does have a limit. Yeah, I guess, and when you do expose those IPs, make sure you protect them from denial of service and web application kind of attacks. Yeah. One final thing I want to leave the audience with. This is very important. When you think DDoS, also think web application attacks. And I'm pretty sure. I think I've taken a demo of what Link 11 does. They also do web application security. So do not only think volume, botnet, but think much more than that.
Yes, absolutely agreed.
So Karsten, sorry, before I go to Karsten, Atish, any final comments on this, and then I'll give it to Karsten.
None from me. I think you just covered the last comment that I was going to make. It's about application security and infrastructure security as a broader topic, not just DDoS.
Yeah, excellent. Karsten, over to you, sir. A few final comments, and then we're done for the day.
Sure, no problem. As I've mentioned before, security is hard, and a lot of the battle is already lost before it begins, simply by exposing too much information to an attacker. So again, the most important thing is to reduce the attack surface, and that means exposing as little as possible. And with that in mind, DDoS attacks still are a problem, but the impact is going to be reduced by a lot.
Excellent.
Thank you.
One final thought has just come to me. Firefighting is that word that's often used. So if you don't want to firefight all your life on preventing your website from going down, you need to invest in such technology, so that you need to invest in technology and something that can automatically reduce your threat, so that you fight the advanced threat rather than the less sophisticated threat. And that's kind of it for now, everyone. I wanted to thank Atish and Karsten from Link 11 and all the attendees that are going to listen in and that have listened in. Do leave us feedback and email us at info@cm-alliance.com. Remember, within an hour or so, we are going to upload the new report, so it should be available for download. Gentlemen, and the rest of the audience, thank you so much.
Thank you.
Thank you. Cheers.